We have already discussed the fact that space is not empty. In this video, we will focus on the invisible ocean flowing through the universe. We call it electromagnetic radiation. It consists of a large range of frequencies and wavelengths that transfer energy throughout the cosmos at the speed of light. Not just the cosmic background radiation, a residue of the Big Bang, but all the other regions included within the spectrum are present in the universe. Radio waves are at one end of this spectrum. Gamma rays are at the other end. Visible light, the light we see, occupies a tiny sliver in between. The ability to detect the different frequencies of electromagnetic radiation is key to understanding the different structures present in the universe. This is because each event or structure emits different bands of radiation. Gamma-ray telescopes have allowed us to observe the most violent cosmic events, such as supernova explosions. We have also discovered active galactic nuclei, which are supermassive black holes at the center of galaxies due to their emission of the full range of electromagnetic radiation, including radio radiation. Radio telescopes have enabled the detection of radio galaxies. As their name suggests, these galaxies have very large regions of radio radiation emitting gas lobes surrounding their core structure. Their ability to transfer energy and information at the speed of light has made it possible to communicate across vast distances, an example being all the spacecrafts that have been sent to planets, and in the case of the Voyagers, to beyond the solar system. Back on Earth, their applications have revolutionized our daily lives. In fact, in relation to the radiation from the sun, electromagnetic radiation is essential to our existence in terms of providing warmth and the energy for plants to perform photosynthesis. What is the source of this radiation? The answer lies in the movement of charged particles such as protons and electrons that are present in atoms. Electrons account for the bulk of the electromagnetic radiation produced in the universe. This is because as leptons they are not subjected to the strong nuclear force, which restricts the movement of protons in the nucleus. Therefore, electrons flow far more freely than protons and generate much greater amounts of electromagnetic radiation. This movement, as well as the spin of proton-containing nuclei, generates a magnetic field. In fact, any moving charge will create a magnetic field. Of course, all movement is relative in terms of the observer and Lorentz transformations. Those details will be covered in a video on field tensors and vector fields. Going back to the case of the electrons. The faster the electrons move, the more energy they carry. The greater the frequency of the electromagnetic radiation produced. Low-energy electrons produce radio waves. High-energy electrons produce gamma rays. The universe is a chaotic dance of charged particles, experiencing different accelerations, thus creating a constant symphony of the different frequencies of electromagnetic radiation. The magnetic field generated by the moving charge is only half the story. To fully understand electromagnetic radiation, we need to understand electric fields as well. An electric field, like a magnetic field, is an invisible force field. It is generated by all charged particles, and unlike magnetic fields, an electric field is generated even if the charged particle is stationary. The strength of an electric field is directly proportional to the product of the charges, inversely proportional to the distance between the square of the distance between them, as laid out in the formula, Coulomb's law. Electric fields are fundamental forces of nature. The electromagnetic force is one of the four fundamental forces whose exchange particles, photons, represent the particle nature of electromagnetic radiation and explain the concept of the photoelectric effect. They govern the interactions between charged particles and are essential to understanding the behavior of matter. To recap, while all charged particles generate an electric field even if they are stationary, magnetic fields are only created when the charges are moving. These two fields are closely interrelated. Disruption of a magnetic field generates an electric field, and movement of a charged particle, a current, generates a magnetic field. Indeed, these two fields are always perpendicular to each other, a testament to the fact that they are the two linked halves of an electromagnetic field. Imagine holding a piece of paper. Now imagine drawing a line across the paper. Then draw another line perpendicular to the first. This is how electric and magnetic fields are oriented. But what is the extent of electromagnetic radiation in the universe? a permanent near-infinite ocean of electromagnetic waves, generated by a near-infinite number of charged particles spread throughout the cosmos. Not just moving, but accelerating. An acceleration which creates a disturbance, traveling through space, oscillating particles it collides with perpendicular to its direction of motion. The greatest importance of these radiation paths is what they tell us about the galactic events which generated them. Events that occurred millions or even billions of years ago. Observing and deciphering this ocean of information has allowed us to better understand the science of star life cycles, galactic life cycles, and the life cycle of the universe itself, as well as communicating with distant spacecraft that we have sent to get a first-hand view of our solar system and beyond. Electromagnetic waves are the messengers of the cosmos. If you like this video, please hit the like button. Subscribe to this channel and hit the notification bell to be alerted to new videos published on this channel. Most importantly, stay curious.